So, good morning, students. How are you? I am Francis sir, and today I am here with class 10 physics, and today we will be dealing with Ohm's law. Okay. So, in the previous lecture, we discussed something about current, electricity, what is electric potential, what is electric current. So, let's take that reference for a bit. Okay. Suppose that we have this electric conductor. Okay, so this is a conductor. Okay, so what is current? Current is equal to Q by T. You know, what is Q? Q is the net charge and T is the time taken. Okay, that means current is what? The rate of flow of charge. And how does charge flow? Charge flows when the electrons flow, because the charges are in the electrons. Okay, so in a way we can say the rate of flow of electrons, it is called current. But how does an electron flow? That we talked about, when we were talking about electric potential. Yes, so what happens that if electrons are to move from this point A to this point B. If the electrons are to move from point A to B, or the charges are to move from A to B, some amount of work needed to be done. Yes? So this work was called your electric potential. So you can understand when the work is done, what happens? The current flows. When the work is done, the current flows, or if the current is flowing, that means the work is being done. If the current is flowing, that means the work is being done. So let's consider about work. For instance, we have this box. This box weighs 1 kg. Okay. If I apply a force of 1 Newton, it will move with a certain amount of force, certain amount of speed. But if I provide it with 2 Newton, obviously I have made more work. That means the rate of work, we can say that with the same amount of force, 1 more kg box could have moved. When I applied 3 Newton force, 1 more box could have moved. So more the work, the more is the current. The more is the current. And if more is the current, that means the more work is being done. So that you should understand. That more the current, more the work is being done, and more the work is being done, that means the more current is flowing. Okay. So that is the thing. So what does Ohm's law state? Ohm's law state that at a particular temperature, the potential difference across the ends of a current carrying conductor is directly proportional to the current flowing across it. So at a particular temperature, the potential difference across the ends of a current carrying conductor, that means this. So what is this work? Work is this potential difference. The potential difference is the work done in moving a unit positive charge from one point to another point. So that is your potential difference. Okay, that is the potential difference. So work done moving charges from A to B, that is your potential difference. So this is the current carrying conductor, and the work is done from A to means from moving a charge from A to B. Okay, so on what factor does this work done depends upon? Means this work done will be depending upon the amount of current we want to flow through the conductor. For example, if I want 1 ampere current to flow, we will do a certain amount of work. But if I want 6 ampere of the current to flow, I will have to do more amount of work. If I have to provide for 12 ampere current, then I will have to provide more amount of work. So the work across the ends is directly proportional to what? Directly proportional to the current flowing across the current carrying conductor. Okay, so we get the expression that, therefore we get the expression that V is directly proportional to I. V is directly proportional to I at a particular temperature. This should be considered. At different temperatures, the work done has to be different. Okay, so now to remove this sign of proportionality, we add a constant here. And that constant is called R. That constant is called R, and this is called resistance. Okay, V is equal to Ri, where R is what? The constant, and its main, and what is this constant? It is called resistance. What it is called? Resistance. So what is resistance? This constant is also a term, and it is also very important. One of the very important factors which goes on to the entire electricity chapter. Okay, so let's talk about this resistance. Resistance. What is resistance? Resistance is the hindrance offered. Now, what is resistance? Resistance is the hindrance offered to the flow of current in a conductor. So hindrance offered to the flow of current in a conductor. So when a current is flowing in a conductor, the hindrance offered to its flow is called resistance. Okay, and since the conductor can be of different types, conductor can be made up of silver, can be made up of copper, can be made up of brass, can be made up of iron. So different conductors have different ability to provide resistance. Okay, and that ability of providing resistance is called resistivity. Okay, but I hope you understood what is resistance. Resistance is the hindrance offered to the flow of current in a conductor. Okay, and this is constant in a particular conductor. This is constant. So this we consider here it as constant. Okay, we consider resistance as a constant because it is fixed in a particular conductor. Okay, so please note it down. So now we will deal with resistance. Okay, so as I told you, what is resistance? It is the hindrance offered to the flow of current in a particular conductor. Okay, so that is about the definition of resistance. So let us see what is the expression for resistance. Resistance can be said as uh, the expression for resistance is rho L by A. Okay, so this is the formula for resistance. Okay, where rho is what? Resistivity. Resistivity. Okay, this resistivity, it is the thing, that varies from material to material. Okay, for instance, resistivity is different for copper, resistivity will be different for brass, resistivity will be different for silver, gold, platinum, different metals, different resistivity. Okay, so this is resistivity. So now you would be thinking that how do we get this expression for resistance? Yes, so actually this resistance, no, it is directly proportional to the length of the conductor. It is directly proportional to what? The length of the conductor. Also, this resistance is inversely proportional to the area of cross section of the conductor. For example, if this is our conductor, so this can be considered as L, and this, this area, this vertical section of this wire, this area, it can be called as A. This is your A. Okay, so resistance is directly proportional to the length of the conductor, this, and resistance is inversely proportional to the area of cross section. Directly proportional means, I hope you understand, means if the length increases, the resistance will increase, and inversely means if the area of cross section increases, the resistance decreases. That means, this expression means this. And when we combine these two expressions, what do we get? R is directly proportional to L by A, and to remove this sign of proportionality, what do? We bring a constant, and that is called rho. What is called? Rho. What is rho? R-H-O, rho. Okay, rho. And what does this mean? As I said, it means resistivity. Okay, and it depends upon what? The nature of the material. That means what type of material is the conductor made of. Either it is made up of silver, brass, copper, bronze, anything. There are different type of metals and different types of conductors. Okay, so this is about our resistance. We will talk more about resistance and resistivity in the next video. Till then, what do? You study well at home. Please go through the videos and go through the book, and please have focus in your syllabus. Okay, see you.